In the previous video, we understood why clean architecture is important, what problems it solves, how the different layers work together, and how a request flow through the application. Now it's time to move from theory to implementation. In this video, we will build the foundation of a production-ready clean architecture application using .NET. We will create our solution, set up all the projects, configure the project references, understand dependency direction, integrate CQRS with the MediatR, and finally build our first end-to-end feature that we can run and test. Throughout this implementation, we will also use AI to make our development more productive. But instead of asking AI to generate the entire application, we will build everything step by step. We will generate one component at a time, review every line of code, understand why it was generated, and improve it wherever necessary. Think of AI as your pair programmer, not as a replacement for your engineering decisions. For this series, we will begin with the Microsoft Copilot so everyone can follow along even without a GitHub Copilot subscription. We will use it to understand the architecture and generate small pieces of a code one at a time. Later in this series, once we are comfortable with this workflow, we will switch to the GitHub Copilot inside Visual Studio to speed up the development. But regardless of the tool we use, we will always review, refine, and validate the generated code before adding it to our application. And that's how AI is used in a professional software development. Before we start coding, let's quickly understand two important concepts we will use throughout this series. The first one is a CQRS. The CQRS stands for Command Query Responsibility Segregation. CQRS simply separates writes operations from the read operations. Commands are responsible for creating, updating, and deleting data. Queries are responsible for retrieving data. This separation makes our application easier to maintain, easier to test, and easier to scale. The second concept is mediator. Instead of controllers directly calling services or the repositories, they send requests to the mediator. Mediator then forwards those requests to the appropriate command handler or query handler. This keeps our controllers clean, reduces coupling between different parts of our application. So don't worry if these concepts feel new right now, you will see them in action as we build the application. Now that we understand the concepts and the approach we will follow, let's switch to the Microsoft Copilot and design our application architecture. Before we jump into coding, let's spend a minute on something that's becoming an essential skill for every software engineer, that is writing effective AI prompts. One mistake many developers make is asking AI to generate an entire application in a single prompt. While AI can certainly do that, but it doesn't help us understand the architecture or verify whether the generated code actually follows our business requirements or not. Instead, we will take a professional approach. We will first define a clear objective for the AI. In this prompt, I am asking Microsoft Copilot to act as experienced .NET solution architect. Rather than generating code, I am asking it to recommend the solution structure, suggest the project we need, explain the responsibility of each project, define the project dependencies, and recommend the correct order in which we should build the solution. You will also notice one very important instruction that at the end of the prompt, do not generate any code yet, and that's intentional. Before writing a single line of code, we first want a solid architectural foundation. Once we are satisfied with the design, we will move on to the implementation one component at a time. Throughout this series, we will use AI as our pair programmer, not as our architect. Every piece of generated code will be reviewed, refined, and validated before it becomes part of our application. This is how AI is used in real world software development. Now let's open the Microsoft Copilot and see what the architecture it recommends. Remember, great software doesn't start with the code, it starts with a great design. Let's paste our prompt here. Okay, so Microsoft Copilot has given us a solid architectural recommendation. Let's quickly review it. The suggested project structure aligns with the clean architecture principles. It clearly separates the responsibilities across different layers and follow the dependency rules as we discussed in part 1. This is exactly what we are looking for. Now remember, this is still a recommendation. As a software engineer, we should never copy and paste AI generated content without understanding it. We will use this recommendation as our blueprint, and now we will build a solution ourselves, one project at a time. This way, you will not only know what to create but also why each project exists and how they work together. Let's switch to the Visual Studio and start building our employee management system. I will begin by creating a new blank solution named Employee Management System. Once the solution is ready, we will add each project one by one and understand the responsibility of each layer before moving on to writing any code. A well-structured solution is the foundation of a maintainable application. Spending few extra minutes planning your architecture can save hours of refactoring later. Let's start by creating new blank solution. I will name it Employee Management System. This solution will contain all the projects that make up our clean architecture application. Keeping everything under a single solution makes it easier to manage, develop, and maintain as the application grows. We will start with the domain project because it's our core of our application. The domain layer contains our business entities, business rules, value objects, enums, and domain logic. One of the most important principle of clean architecture is that domain layer should remain completely independent. It should never depend on any framework, database, or any external library. Everything else in our application revolves under around this layer. Now let's create the application project. This is where our application use cases live. It contains CQRS commands, queries, handlers, DTOs, repository interfaces, and validation logic. The application layer depends only on the domain layer and knows nothing about how the data is stored. Now let's create the infrastructure project. This layer contains all external implementations such as entity framework, SQL Server repositories implementations, logging, and any third party integrations. By keeping these concerns separate, we can change technologies in the future without affecting our business logic. And finally, let's create the API project. This is the entry point of our application. It exposes REST APIs, receives HTTP requests, and delegates them to the application layer. Notice that the controller doesn't contain business logic. Its responsibility is simple to receive requests and forward them to the appropriate handler. Our solution structure is now ready. Before we add project references, there is one important rule that every clean architecture developer must understand. Let's take a look at how dependency should flow between these projects. Dependencies should always point inward. The domain layer doesn't depend on anything. The application layer depends only on domain. Infrastructure depends on application and domain. The API project depends on the application layer. Following this dependency direction keeps our architecture loosely coupled, maintainable, and easy to test. Now, let's configure our project references according to these dependency rules. The application project needs access to the domain project, so let's add that reference. The infrastructure project implements interfaces from the application layer and works with the domain entities, so it references both application and domain. Finally, the API project communicates with the application layer, so we will add the application reference there. Our project dependencies are now configured correctly and our clean architecture foundation is in place. Now we are ready to start implementing our first feature. The next step is to start building our domain model. As we discussed earlier, we will generate one component at a time, review it carefully, and then integrate into our application. Let's start with the most important business entity in our application, that is employee. Instead of writing everything manually, let's ask Microsoft Copilot to generate production ready employee entity that follows clean architecture and object oriented design principles. I have pasted the prompt here to generate our employee entity. Let's review the generated code before adding it to our project. This is one of the most important steps when working with AI. Never assume the generated code is a perfect. Always review it to ensure it follows your business requirements, coding standards, and architectural principles. Okay, it has generated the properties as we have provided in the requirements. Let's check it. The ID uniquely identifies an employee. First name and last name represents the employee's basic information. Email gives us a unique way to communicate with the employee. Department ID establishes the relationship between the employee and a department. Created on help us track when the employee record was created. This looks like a good starting point. Let's copy the code into our domain project and make any refinements if needed. Our employee entity is now ready. The next question is, how will our application layer communicate with the database? Should it directly use entity framework core here? The answer is no. Doing so would strictly couple our business logic with a specific technology, which violates one of the key principles of clean architecture. Instead, we will define a contract inside the application layer. The infrastructure layer will provide the actual implementation. This approach follows the dependency inversion principles and keeps our business logic completely independent of our database. Let's ask Microsoft Copilot to generate a repository interface for our employee entity. I have pasted the prompt here to generate a repository interface for our employee entity. Let's review the generated interface before adding it to our project. Let's review the each method. Add async is responsible for creating a new employee. Get by ID async retrieves a single employee. Get all async returns all the employees. Update async updates an existing employee. Delete async removes an employee. Notice that we are defining what needs to be done, not how it's done. That's exactly the responsibility of an interface. The actual implementation will come later in the infrastructure layer using Entity Framework Core. This separation gives us flexibility to change the implementation in the future without affecting our business logic. Let's copy this interface to our application project. So far, we have created our employee entity and defined the repository contract. Now let's implement our first business use case, and the requirement is simple: create new employee. In CQRS, any operation that modifies the data is represented as a command. Since we are creating a new employee, we will create a create employee command. So again, instead of writing manually, let's ask Copilot to generate production ready command. Pasted the prompt here and let's review the generated command before adding it to our project. Notice that this command contains only the data required to create a new employee. It doesn't contain any business logic. Its only responsibility is to carry data from controller to the handler. This is an important distinction. The employee entity represents our business model. The create employee command represents a user request to create that entity. These two have different responsibilities, and keeping them separate in one of the key ideas behind the CQRS. Now let's add this command to our application project. Here we have added the MediatR package, and this package supports the CQRS pattern. Here in the class we have referenced it using MediatR, and this interface here I request is coming from that package, and that interface help us to implement our CQRS pattern. Our command is now ready, but remember, a command is simply a request. It doesn't contain any business logic or execute any operation. So the next question is, who processes this command? That's exactly where the command handler comes in. Think of the command handler as the person responsible for fulfilling the request. It receives the command, performs the required business logic, communicates with the repository if needed, and finally returns the result. Every command in CQRS has exactly one corresponding handler. Now let's ask Microsoft Copilot to generate a production ready create employee command handler. I have pasted the prompt here to generate our create employee command handler. Let's review the code. Here, the first thing you will notice is a constructor injection. Instead of creating the repository inside the handler, we are asking .NET's dependency injection container to provide it. This makes our code loosely coupled and much easier to test. The handle method is where the actual work happens. It receives the command, creates a new employee entity, calls the repository to save it, and returns the newly created employee. Notice how all the business logic is centralized inside the handler. The controller doesn't know how an employee is created. The repository doesn't know who requested it. Each component has a single responsibility, which keeps our architecture clean and maintainable. Okay, so this handler looks good now. Let's add this handler to our application project. Our command handler is now complete. However, it's still using an interface. Interfaces only define a contract. They don't contain any implementation. Now it's time to move to the infrastructure layer and provide the actual implementation using Entity Framework Core. Let's start by creating our employee DB context. The DB context is responsible for managing our database connection and tracking the changes to our entities. Let's go to the Copilot and paste our prompt. I have pasted our prompt here to generate employee DB context, and it has generated our data access layer as employee DB context. And also, if you see below, it has defined the connection string in our configuration file, that is appsetting.json. And also it has given some configuration to do on a startup.cs. So this will register our employee DB context as a dependency injection, and it will pass our connection string from the appsetting.json. So now let's copy this configuration in our project. We have now generated our employee DB context and added it to the infrastructure project. The DB context is responsible for managing our database connection and tracking changes to our entities through the Entity Framework Core. Notice that DB context itself doesn't contain any connection string. That's intentional. In a clean architecture, environment-specific configuration should not live inside the infrastructure layer. To keep our solution clean and maintainable, I have created a separate infrastructure dependency injection class. This class is responsible for registering all infrastructure services, including the DB context, repositories, and any future external dependencies. Keeping this configuration in one place make our startup code much cleaner and easier to maintain. The SQL Server connection string is defined inside the appsettings.json file of API project. The API project is the entry point of our application, so it owns the application configuration. During the application startup, we pass the application configuration to the infrastructure layer. The infrastructure layer reads the connection string and configures Entity Framework Core without needing to know where the configuration came from. This keeps our layers properly separated and follows the clean architecture principles. Finally, in the program.cs, we have registered the entire infrastructure layer with the single extension method. This keeps the startup code clean and allows the infrastructure project to manage its own dependencies. Our database configuration now complete and the foundation is in place. The next step is to implement the repository that we will use this DB context to persist and retrieve the employee data. Now let's paste our prompt to the Copilot and generate the code for the implementation of iEmployee repository interface. Pasted the prompt here to generate employee repository implementing employee repository interface. So it looks good, like it has implemented all the required method. Let's copy this code to our infrastructure project. Notice that application layer only knows about the interface. This concrete implementation lives inside the infrastructure layer. This is one of the biggest advantage of clean architecture. Now we need to register it with the dependency injection so the .NET knows which implementation to provide whenever our application request and employee repository. Pasted the prompt here to generate the dependency injection registration for our infrastructure layer. Just take a look at the code. Here it has registered our employee repository and employee repository class. So let's copy this code to our application. This configuration tells ASP.NET Core that whenever someone requests an employee repository, it should provide an employee repository instance. Now let's create the final piece of our application, that is API controller. Pasted the prompt here to generate our final employee controller. Let's copy this controller to our API project and take a look. Notice how clean this controller is. It doesn't contain any business logic. It simply receives the request and forwards it to the mediator. Everything is now connected. Let's run the application and verify that our first end-to-end feature works successfully. Excellent. Our application is now up and running and Swagger has been launched successfully. This is the moment where we will verify that all the pieces we have built are working together as expected. Let's test our first API. This endpoint is responsible for creating a new employee. I will click try it out and provide the required employee details. Once I click execute, the request will begin its journey through our clean architecture. Perfect. As you can see, the request has been processed successfully. This confirms that our project structure, dependency injection, CQRS implementation, entity framework configuration, and API are all working together correctly. Let's confirm this entry also has been saved in the database. So you can see here the entry also successfully saved in database. Now that we have seen the application working end to end, let's visualize exactly how this request traveled through our application using the clean architecture request flow. The client sends request to the API controller. The API forwards the request to the mediator. Mediator locates the appropriate command handler. The command handler executes the business logic, communicates with the repository, and returns the response. This clear separation of responsibilities is one of the biggest advantage of combining CQRS with the clean architecture. So, we have successfully built the foundation of our clean architecture application. We created the solution structure, configured the project dependencies, integrated CQRS with the mediator, and implemented our first end-to-end feature. More importantly, we also learned how to use AI as a professional development assistant, planning first, generating code step by step, and carefully reviewing every piece of code before adding it to our project. This foundation will support every new feature we build throughout this series. If you found this video helpful, don't forget to like this video, subscribe to the Pattern Forge, and share it with others who want to become better .NET developers. Thank you for watching, and I will see you in the next video.